Imagine a scenario where the unthinkable becomes reality, where the vast, icy giant Uranus deviates from its distant orbit and sets on a direct collision course with Earth. This is a story of cosmic proportions and a speculative journey into what would happen if the celestial dance went awry, bringing these two planets together in a cataclysmic embrace. What forces would set such an event in motion, and what would this celestial clash's aftermath? Delve into a universe where the boundaries of imagination and reality blur, exploring the impacts of a collision that would reshape our world and challenge our understanding of the cosmos. In our solar system's vast, silent expanse, two worlds drift through the void, each following their millennia-old paths around the sun. Earth, our familiar, bustling home, teeming with life and cloaked in a thin, protective atmosphere, contrasts starkly with the distant, icy giant Uranus. Uranus, a world of mystery and extremes, orbits far from the sun's warmth, enveloped in a thick, cold blanket of gas, its unique tilt casting its moons into unusual orbits. This documentary embarks on a speculative journey that defies the laws of physics as we know them, to explore a scenario as catastrophic as it is unlikely: the collision of Uranus with Earth. Such an event, unprecedented in the recorded history of our solar system, would not only spell doom for our planet, but also offer a lens through which to examine the forces that shape our cosmos. With its colossal size, 4 times wider than Earth, Uranus and its massive atmosphere composed of hydrogen, helium, and traces of water, methane, and ammonia, it stands as a giant sentinel in the outer solar system. Its icy nature and the mysterious energy source that heats its core remain subjects of intense study. In contrast, Earth's rocky composition, liquid water, and dynamic atmosphere teems with life and geological activity. The hypothetical scenario we explore today involves Uranus being knocked from its distant orbit to hurtle toward Earth by some extraordinary force. The sheer improbability of such an event cannot be overstated. It would require a force beyond our current understanding of physics and celestial mechanics. Yet, in indulging this hypothetical, we delve into the scientific, environmental, and speculative impacts of such a cataclysm. Our journey through this scenario is not just one of destruction and theoretical physics. It is an exploration of the fragility of our existence, the power of natural forces, and the boundless curiosity that drives us to ask, what if? As we consider the astronomical considerations of such an event, the energies involved, the gravitational dance, and the eventual cataclysmic impact, we embark on a narrative that is as much about understanding our universe as it is about appreciating the delicate balance that allows life to thrive on our blue dot in the cosmos. In pondering the collision between Earth and Uranus, we confront the limits of our knowledge and our imagination. We engage with the forces of gravity, the vast distances that separate the planets, and the intricate ballet that keeps them in their orbits. This discussion serves as a doorway to broader questions about our place in the universe, the nature of the cosmos, and the future of our planet. Through this speculative lens, we seek not just answers, but also a deeper appreciation for the majesty and mystery of the space we inhabit. As we venture further into this dramatic exploration, let us keep in mind the purpose of our journey: to ignite curiosity, to broaden our understanding of the cosmos, and to remind ourselves of the beauty and fragility of our world. The collision of Uranus with Earth, while a scenario steeped in speculation, offers a unique perspective on the forces that govern our solar system and the infinite possibilities that lie beyond our current understanding. Our cosmic drama sets the stage for an unimaginable event. Uranus embarks on a trajectory toward Earth. This section dissects the gravitational mechanics and colossal energy required to wrench Uranus from its distant orbit, setting it on a collision course with our planet. Such a deviation from the known laws of physics invites us to suspend disbelief and delve into a world of theoretical possibilities. For Uranus to abandon its serene, distant orbit around the Sun and hurtle toward Earth, an unfathomable force must act upon it. This force would have to overcome the Sun's gravitational grip on Uranus, which orbits at an average distance of approximately 2.9 billion kilometers from the Sun. The energy required for such a feat would dwarf any natural occurrence presently understood by astrophysicists, requiring perhaps a rogue star, or an unimaginably massive object passing through our solar system to impart the necessary gravitational disturbance. Once set upon its new, cataclysmic path, the speed and timeline of Uranus's journey toward Earth depend on the initial velocity imparted by this hypothetical force. If accelerated to a fraction of the speed of light, the journey could take mere hours or days, an eventuality that defies the slow, stately dances typically observed in celestial mechanics. More realistically, assuming velocities achievable by known cosmic events, the voyage could span years or even centuries, offering a haunting countdown to an inevitable apocalypse. As Uranus approaches, its gravitational influence on Earth would manifest long before the actual collision, heralding the impending doom through subtle yet increasingly catastrophic interactions. The gravitational pull of Uranus, significantly more massive than Earth's moon, would exert profound tidal forces on our planet. Ocean tides, driven to monstrous heights, would devastate coastal areas far beyond any historical precedent. But the effects would not be limited to the oceans. The Earth's crust itself, subjected to these immense tidal forces, could experience heightened volcanic activity and earthquakes as it strains under the gravitational stress. The gravitational dance between Earth and Uranus as they draw near would also have profound effects on Earth's orbit and rotation. The Earth could be pulled into a more eccentric orbit, causing extreme fluctuations in climate and temperature. Moreover, the rotational period of Earth might be altered, affecting the length of day and night, disrupting the delicate balance of life adapted to the current rhythm of our planet. The final act of this cosmic drama, the collision scenario, unfolds with a spectacle beyond human comprehension. As Uranus fills Earth's sky, its towering ice giants and moons looming over us, the first contact would likely vaporize the atmosphere in a catastrophic display of energy release. The collision itself, an event of unimaginable violence, would meld the two worlds into a new molten entity, eviscerating all traces of life and drastically altering the solar system's layout. This hypothetical journey, from Uranus's improbable departure from its orbit to the cataclysmic collision with Earth, serves as a dramatic exploration of celestial dynamics, gravitational forces, and the sheer power of the cosmos. It underscores the delicate balance that allows life to exist on Earth and invites us to marvel at the wonders and mysteries of the universe that surrounds us. Through this speculative lens, we gain not just insight into the mechanics of the cosmos, but a deeper appreciation for the fragile, fleeting nature of life itself within the vast expanse of space. The collision between Uranus and Earth, a spectacle of cosmic proportions, brings forth an event of such magnitude that it reshapes the very fabric of our solar system. This segment delves into the immediate aftermath of this cataclysm, examining the scale of destruction, the astronomical energy released, and the resultant cascade of environmental consequences. Uranus, with a diameter of about 51,118 kilometers, more than 4 times that of Earth's, and a mass approximately 14.5 times greater colliding with our planet, is a scenario of unimaginable proportions. Earth, modest in size but vibrant with life, stands no chance against the sheer bulk of the ice giant. The disparity in size and mass means that the impact would not be a meeting of equals, but rather the engulfment of Earth by Uranus, leading to an unparalleled cosmic upheaval. The kinetic energy released at the moment of impact can be approximated by considering the mass of Uranus and its velocity as it collides with Earth. This energy, likely exceeding anything humanity has ever witnessed, would be sufficient to vaporize the Earth's crust and mantle, and significantly alter the structure of Uranus itself. The exact figures verge on the incomprehensible, dwarfing the energy produced by the Sun in an entire year. The collision would hurl an immense amount of debris into space, including fragments of Earth's crust, portions of Uranus's atmosphere, and possibly even pieces of Uranus's moons. This material, now hurtling through the solar system, could impact other planets and moons, creating craters and potentially altering their orbits. The solar system would be littered with the remnants of Earth and the scars of this catastrophic event, a stark reminder of the destructive potential of cosmic forces. The immense energy release would also result in global heating on a scale beyond Earth's current climatic concerns. The immediate vicinity of the collision would reach temperatures higher than the surface of the Sun, obliterating any form of life and transforming the atmosphere into a fiery, toxic maelstrom. This heat would contribute to a prolonged period of elevated temperatures across the remnants of Earth, assuming it survived in any recognizable form, fundamentally altering the planet's climate and atmospheric composition. In the wake of the collision, the environmental consequences would be profound and multifaceted. The debris cloud enveloping the planet could block out the sun for centuries, initiating a nuclear winter scenario. Photosynthesis would halt, collapsing the food chain and leading to mass extinctions on a scale far beyond the dinosaurs' demise. The atmosphere, now thick with particulate matter, would undergo chemical transformations under the intense heat, potentially rendering it inhospitable for millennia. The oceans, if they survived, would be heated to the point of evaporation, contributing to a greenhouse effect that could further destabilize any remaining vestiges of the environment. The impact's seismic energy would trigger global volcanic eruptions, releasing more ash and toxic gases into the atmosphere, compounding the catastrophic climate effects. This apocalyptic vision, while speculative, serves as a stark reminder of the delicate balance that sustains life on Earth. It underscores the importance of understanding and respecting the cosmic forces at play in our universe. As we explore these hypothetical scenarios, we are reminded of our vulnerability in the vast expanse of space and the preciousness of the only home we currently know. The collision between Uranus and Earth would bring about unprecedented changes in the composition and density of Earth's atmosphere. The event, characterized by its extreme energy release, would not only vaporize much of Earth's existing atmosphere, but also introduce vast quantities of Uranus's gaseous components. The new atmospheric composition would likely be dominated by hydrogen and helium, the primary constituents of Uranus's atmosphere, alongside significant amounts of methane, water vapor, and ammonia. This radical alteration would increase the atmosphere's density at higher altitudes, potentially enveloping the planet in a thick, opaque cloud layer. Such changes would render Earth's atmosphere unrecognizable and hostile to life as we know it, stripping away the protective layer that shields us from solar and cosmic radiation. The introduction of Uranus's gases could lead to the formation of a new atmosphere, one characterized by extreme temperatures and pressures, and composed of elements and compounds alien to Earth's current biosphere. This new atmosphere would likely be inhospitable to all known forms of terrestrial life, fundamentally altering the planet's surface conditions and possibly giving rise to new, unimaginable forms of chemical interactions. The immediate and long-term climate effects of the collision would be catastrophic, with the potential to alter Earth's climate systems beyond recognition. The immediate aftermath would likely see a dramatic spike in global temperatures due to the immense heat generated by the impact. Over time, however, the particulate matter and debris ejected into the atmosphere could lead to a significant reduction in solar radiation reaching the planet's surface, initiating a global cooling effect. The blocking out of the sun by the thick dust and debris cloud could trigger a nuclear winter scenario, characterized by global temperature drops, failing ecosystems, and collapsing agricultural systems. Conversely, if the atmosphere becomes enriched with greenhouse gases like methane and water vapor from Uranus, a runaway greenhouse effect could ensue, leading to extreme global warming. The ecological impact of the collision would be devastating, leading to mass extinction events and dramatically altering the course of evolution on Earth. The drastic changes in climate, atmosphere, and solar radiation would likely lead to mass extinctions on a scale far greater than any previous event recorded in Earth's history. Few, if any, species would be expected to survive the initial impact and the subsequent environmental upheavals. The reduction in solar radiation reaching Earth's surface would disrupt photosynthesis, leading to the collapse of plant-based ecosystems and the food chains that depend on them. The long-term biological impacts would include the possible evolution of life forms adapted to the new, harsher environmental conditions, should any semblance of a biosphere remain. The human and societal impacts of such a catastrophic event are difficult to overstate. The immediate loss of life would be followed by the breakdown of social, economic, and political structures worldwide. The survivors, if any, would face unimaginable challenges in adapting to the new world, with the basic necessities for sustaining human life, clean air, potable water, and food, becoming scarce or non-existent. In the face of such adversity, the resilience and adaptability of humanity would be put to the ultimate test. Societal rebuilding efforts would have to contend with the drastically altered environmental conditions, seeking new ways to sustain human life and community in a world forever changed by the cosmic encounter with Uranus. This speculative exploration, while rooted in the dramatic and the hypothetical, serves as a profound reminder of our planet's vulnerability in the cosmos. It underscores the importance of advancing our understanding of the universe, not only to satisfy our curiosity, but also to prepare for the unforeseen and to cherish the delicate balance that makes Earth habitable. In the aftermath of a collision with Uranus, the potential for human survival would hinge on the ability to foresee and mitigate the immediate dangers, securing shelter and accessing vital resources. The initial phase of survival would involve navigating a world fundamentally altered by the impact, where conventional means of sustenance and shelter may no longer be viable. The survivors would need to find or construct shelters capable of withstanding extreme temperatures, both hot and cold, and protecting against the increased radiation levels resulting from the altered atmosphere. Access to clean water and food would become paramount, with traditional agriculture likely decimated. Survivors might turn to underground sources of water and food storage technologies developed prior to the collision. The immediate dangers would not only include the harsh environmental conditions, but also the potential for societal collapse, as law and order give way under the strain of the catastrophe. The long-term project of rebuilding civilization in this drastically changed environment would require rethinking many of the foundational aspects of human society, from social organization to the technologies and energies that sustain us. Rebuilding civilization would necessitate a radical adaptation to the new world. This could involve developing new forms of agriculture adapted to the altered climate and atmospheric conditions, establishing new social and political structures to replace those lost, and innovating in the realm of energy production to ensure sustainability in the absence of traditional resources. Given the potentially inhospitable conditions on Earth post-collision, space exploration and colonization could emerge as vital survival strategies. The remnants of human civilization might look to the stars for a new home, investing the remaining resources in technologies capable of reaching other planets or moons within our solar system deemed suitable for human life, or even beyond. This dire situation could accelerate advancements in space travel, habitation, and terraforming technologies, driven by the necessity of finding a new home for humanity. The speculative nature of this scenario allows for exploration into the realms of theoretical physics and the potential outcomes of humanity's attempts to survive and adapt in the post-collision world. The collision with Uranus could spur new theoretical insights into physics, particularly in understanding gravitational dynamics, energy transfer, and the behavior of matter under extreme conditions. These insights might pave the way for breakthroughs in energy generation, material science, and even the manipulation of space-time, offering new tools for the survival and advancement of the human species. As humans adapt to their new environment, we might see the emergence of new societies and cultures shaped by the challenges of the post-collision world. These societies could develop unique approaches to governance, community, and sustainability, reflecting the lessons learned from the catastrophe and the imperatives of survival in a changed universe. In the long term, the legacy of the collision could be the birth of an interstellar human civilization. Driven from Earth by necessity, humanity could spread across the stars, carrying with it the memories of Earth and the lessons learned from its near destruction. This diaspora could lead to the flowering of human cultures across the galaxy, a testament to the resilience and adaptability of the human spirit. In contemplating the collision of Uranus with Earth, we delve into a realm of speculation that challenges our understanding of the universe and our place within it. This exploration, while rooted in hypotheticals, serves as a profound meditation on the fragility of human civilization and the boundless potential for adaptation and renewal in the face of unimaginable challenges. The notion of massive celestial collisions, such as that between Earth and Uranus, invites a foray into the theoretical realms of physics, where alternate realities and dimensions offer intriguing possibilities. From the perspective of theoretical physics, such cataclysmic events could serve as gateways to understanding the fabric of the universe, potentially revealing the mechanisms behind quantum entanglements, parallel universes, and the multiverse theory. In theoretical physics, the extreme conditions generated by a massive celestial collision could create scenarios where the conventional laws of physics are stretched to their limits. Some theories suggest that under such extreme energy and gravitational conditions, it might be possible to observe or even create wormholes, bridges through space-time that could connect distant points in the universe, or even link to alternate realities and dimensions. Such events could offer unprecedented testing grounds for hypotheses regarding the structure of the cosmos and the potential for interdimensional travel. The collision between Uranus and Earth would not only have a catastrophic impact on both planets, but would also reverberate throughout the solar system, altering its structure and the orbits of its planetary bodies. The gravitational shock waves emanating from the collision would have the potential to disrupt the delicate gravitational ballet that maintains the solar system's current structure. Planets and moons could be nudged into new orbits, potentially leading to further collisions or causing some bodies to be ejected from the solar system entirely. The asteroid belt and Oort cloud could be disturbed, sending a flurry of comets and asteroids into the inner solar system, increasing the risk of further impacts. In the wake of such a cosmic upheaval, the conditions for life throughout the solar system and beyond could be dramatically altered, presenting both challenges and opportunities for the emergence of new life forms. The disruption of planetary orbits and the introduction of new chemical compounds and energy sources into the environments of surviving or newly formed celestial bodies could create niches for life that are vastly different from those currently known. In the chaos of a restructured solar system, moons or planets that were once barren could find themselves with the ingredients necessary for life. Life, as demonstrated on Earth, exhibits remarkable resilience and adaptability. Astrobiological theories posit that life could arise in a wide range of environments, from the subsurface oceans of icy moons to the atmospheres of gas giants. The new conditions created by the collision and subsequent solar system rearrangements could lead to the evolution of life forms adapted to these new realities. These beings might possess biochemistries and survival strategies vastly different from terrestrial life, potentially offering new insights into the nature of life in the universe. The exploration of massive celestial collisions through the lens of theoretical physics, impacts on the solar system, and astrobiological considerations opens a vast field of speculative inquiry. This thought experiment not only stretches our imagination, but also deepens our understanding of the universe's dynamic nature, the fragility of our place within it, and the boundless potential for life in its myriad forms. This exploration into the hypothetical collision of Uranus with Earth has traversed the realms of astronomical phenomena, theoretical physics, and speculative outcomes, painting a picture of a universe in which the improbable becomes reality. We've delved into the gravitational mechanics that could send Uranus hurtling toward Earth, the catastrophic impact such a collision would entail, and the immediate and long-term consequences for our planet, its atmosphere, climate, ecology, and human society. We began with the astronomical and gravitational considerations that would underpin such an event, examining the energy and forces required to dislodge Uranus from its orbit and the dramatic effects of its path toward Earth. The collision scenario itself, marked by an unfathomable release of energy, would lead to material ejecta, global heating, and the creation of a new alien atmosphere derived from Uranian gases. The ecological and human impacts were considered next, highlighting the potential for mass extinctions and the challenges to immediate survival. We pondered the long-term societal changes necessary for humanity to rebuild in the aftermath, including the potential turn towards space exploration and colonization as a survival strategy. This speculative journey underscores the importance of understanding cosmic events and their potential impacts on Earth. While the scenario of Uranus colliding with Earth remains firmly within the realm of speculation, it serves as a powerful reminder of the dynamic and sometimes volatile nature of the universe. Our planet's history is punctuated by celestial events that have shaped the course of life on Earth, from the formation of the Moon to the asteroid impacts that have triggered mass extinctions. Speculative science, while exploring scenarios that may never come to pass, plays a crucial role in expanding our understanding of the universe and our place within it. It challenges us to think beyond the confines of current knowledge and technology, to imagine not just what is, but what could be. This exercise in speculation is not just an academic pursuit, but a way to prepare for the unknown. It encourages the development of new technologies, theories, and strategies that could one day be crucial for the survival of humanity in the face of unforeseen cosmic events. However, this speculative journey also highlights the importance of real-world preparedness for astronomical events. While a collision with Uranus is beyond the realm of current possibility, other, more likely celestial events, such as asteroid impacts or solar flares, pose real and present dangers. By studying the universe and its many phenomena, we equip ourselves with the knowledge and tools to mitigate these dangers, safeguarding the future of our planet and species. In closing, the exploration of what might happen if Uranus collided with Earth serves as a compelling narrative through which to appreciate the vastness of the cosmos, the fragility of our existence, and the boundless potential of human curiosity and ingenuity. It is a reminder of the balance we must maintain between speculative science and real-world preparedness, ensuring that as we gaze toward the stars, we remain grounded in our responsibility to protect and preserve our pale blue dot.